Hello everyone, I am the leader in the structural department, and I'm here to discuss the methods of construction that of 3D printing. I will discuss the economic standpoints, the environmental, and the feasibility of design and uh, model representations of our projects. Economically, we use manpower to produce formworks and the like, whereas in new methods of construction, we can produce these formworks quickly and accurately and without as many people to herd around. The formworks we create can be temporary or integral to the foundations, and then you can simply pour in the materials. This is a far cry faster than most conventional construction methods, which take many people and also clean up afterwards after the cement has solidified, instead of just simply leaving it as it was and it's completed after it's poured. One of the methods of construction we printing this is an example of a house that was produced in the Netherlands. They made this in 24 hours and it cost them less than $4,000. The implications of this are immeasurably useful. You can use these for disaster relief, and of course it's cheap and quick, as well as simply the understanding of this is that you can make things quicker in general. This is 800 square feet and takes 24 hours. So physically, if you had a 2,000 square foot house, you would have a 2 to 3 day build time just for a building that would have taken weeks to produce. This is also more efficient. It's also more efficient because it doesn't remove it uses less material inside the walls, and it's also an opportunity to fill those walls, which we'll see later. Here are a few methods of building cement-based buildings. One is select a binder. You simply put down the aggregate and material you want that's slightly wetted, and it'll inject the binder into material. The second is paste intrusion, which takes the binder, the Portland cement, and some sand and mix it together and protrude it on or extrude it onto the building in question and create layers, which we'll see in the next slide. Binder jetting is useful for formwork. You simply place it in layers and you just wet down the material with the binder mixture and water, and it produces our cement or concrete we are used to. Here's the picture of a lattice work that's been produced. This reduces the concrete by 27%, the concrete usage by 70%, and allows you to perhaps even fill those gaps with insulation or leave empty. This allows you to either leave it empty and fill them, but also saves money in time, because this takes really 24 hours for standard house to be built. This will produce insulative effects and save materials. We use software every day to produce our designs, and this can be easily used by the printer and sliced into two-dimensional layers that they can interpret into those little layers to build up the walls. And also, because you can you can create stages in your project, this is easy to replicate in the printing process, and it'll stop at certain stages to complete certain parts of the project, and then continue printing. Here are some conceptual ideas that they've shown to display their capabilities. Is complex. It can be complex and irregular, and also cantilevers out as a property of the cement they use. You can add an active binder to an activator to quickly set the cement, and it can produce things like this. This is steel. You can use steel as a printing method as well. It's quite useful for cantilever bridges And it just uses the industrial rotor arm and our normal MIG welding methods to produce, because it just spits out some metal and it runs a bead across. And this can be replicated into an even bigger project as well and replicated in that way. We can use this printing method for models. It's quite useful because you can use plastic and cheap material, and it takes a short amount of time relatively. While you're still doing your other project, you can have this running in the background to later on show this to your clients. It is a very effective way of showing how you will, the end result will be. So we discussed the economic standpoints and some examples, and as well as some models and modeling and software you use to produce our work. And this is by far the most effective and efficient way of construction. It does not by any means have to be all automated, but it does help with the arduous and thick portions of our project. Thank you for your time.